Okay, in this video we're going over the 7.6 practice set solutions using our calculator to find the measure of angle A. So we're going to use SOHCAHTOA for all of these problems, and for the first one I'm given the opposite leg of A and the hypotenuse, so I'm going to use sine. Sine of the angle A equals 5/9, so in order to solve for the angle, I need to use the inverse sine, and I get A equals the inverse sine of 5/9. And now I use my calculator, make sure I use the inverse sine or the arc sine, and I get 33.7 degrees. Number 2, I'm looking for angle A. This time I've got the opposite leg 9 and the adjacent leg 15, so I'm going to use tangent this time. Tangent of A equals 9/15, and 9/15 reduces to 3/5, so I'm going to find the inverse tangent of 3/5, and I go to the calculator again for this, and I get about 31.0 degrees. Number 3, angle A, I've got the adjacent leg is 32 and the hypotenuse is 45, so this time I'm going to use cosine. Whenever we're looking for an angle, we have to use the inverse of the trig function. If we are looking for the side and we're given an angle, we just use the regular sine, cosine, or tangent. We don't use the inverse. So this time I get 44.7 degrees for angle A. Okay, next set. 10 through 12, solve the following right triangles. So we're looking for all three sides and all three angles. So for number 10, I'll write what I know. I know 2 out of the 3 angles. I can find the third angle by using the triangle sum theorem. All angles of a triangle add up to be 180, so we can find angle A is 38 degrees. Now I know all 3 angles, and I know one side, so I can find side BC by using angle 52 and the opposite leg 12, and I use tangent. This time I don't use the inverse tangent, just regular tangent. 12 divided by tangent 52 is 9.4. Now I can find side CA, which is the hypotenuse of the right triangle. And I can use sine this time because I know the opposite side is 12. Since 12 is a given value, it's better to go with sine instead of cosine in this case, because 9.4 is a rounded value. I'm going to get a little bit more of a precise answer if I use my given values. 15.2. Okay, so number 10 is solved. I found all the missing sides and angles. Okay, so for 11 and 12, it's the same thing. I'm going to write down what I know, what I don't know, use the tools available to me to solve for the sides and the angles. I know 2 out of the 3 sides of the right triangle. I can always go to the Pythagorean theorem. And this time I'm going to simplify it in radical form. And I get 4√10. Now to solve for angle A and angle B, I can use tangent for both because I know the opposite and adjacent legs for both. And I can solve these by using the inverse tangents. So angle A will be the inverse tangent of 1/3. Angle B will be the inverse tangent of 3/1. Those are reciprocals for tangent using the different acute angles of the triangle. There it is. Notice that these angles are complementary. 18.4 degrees and 71.6 degrees add up to be 90. So I think you get the idea for number 12. We're given 2 out of the 3 sides and 1 out of the 3 angles, and we can use all the tools at our disposal to find these missing elements. And just pause the video if you need to at any point. Okay, number 20. Elizabeth wants to know the angle at which the sun hits a tree in her backyard at 3 p.m. She also wants to know the height of the tree. She finds the length of the tree's shadow is 24 feet. The same day, her shadow is 6 feet 5 inches, and she stands 4 feet 8 inches tall. So I'm setting up the drawing here. We know that these 2 triangles will be similar triangles. If we know her height and her shadow, we can calculate the angle of the sun, which we use inverse tangent. We can get an angle of 54 degrees. This would be the same as the sunlight hitting the tree. So if we know the opposite side of the tree, we can find the adjacent with the angle by using tangent again. And you can see the conversions that I've made from inches to feet and the other calculations here. This is a pretty simple problem based on the premise that the sun's rays are all parallel. And then we get our final answer. Done. Okay, so I hope that video on inverse trig functions was helpful for you.